Hello everyone. Today we are going to discuss the concept of convolutional code. Convolutional code. It was firstly discovered by Elias in 1955, and this code was discovered as an alternative to the linear block code and cyclic block code. So if we see the block diagram of convolutional encoders, let's say this is the convolutional encoder, so we're going to apply some input to this convolutional encoder, and this convolutional encoder will add some extra bits in the original message sequence and we'll get some output code word. So how this convolutional encoder is supposed to be looking like? So this is what the design of the convolutional encoder. This convolutional encoder is having this design. So let us see first of all the construction of the convolutional encoder. So in the construction, the convolutional encoder is consisting of some of the shift register D0, D1, D2. You may use any number of shift register, it depends according to the design. It is also composed of some XOR gates, and switch is also there, at the output of which we are getting the convolutional code. Every XOR gate will be giving us the bit in the output code word. So this is what the construction. Now let us look at the working. So in the working, the message signal we're going to apply only to the first shift register. So when the first message bit is entered in the shift register, actually initially what we have considered, initially the content of the shift registers are vacant, so no contents are available. Now when the first message bit is entered into the D0, so accordingly we will get the output of adder 1, adder 2 and adder 3, and this switch is connecting to the terminal number 1 first, 2 next and 3 next, and therefore we are getting the output code word C. So for the first message bit, when it enters into the D0, we will get 3 bits in the output code word. Now when the second bit is coming from the message, it will be stored in D0, and whatever the contents available in D0, it will be shifted to the D1. Once again we are getting the 3 bits at the x1, x2, x3, which will be sent by this switch as to the output. Now during these 2 bits, the contents of the D2 is still remain vacant. Now when the third bit is going into the D0, so content of D0 will be shifted into D1, the content of D1 will be shifted into the D2, and accordingly we are getting the output. So this process will remain continue until and unless the last message bit will not reach to the last shift register. So with the help of example, let us try to understand the operation of this convolutional encoder. So let me take here the example. So let us consider, suppose we are having the message sequence. Let's say m is equal to 1 0 1 1. So for this message sequence, let us look at what will be the output we are getting here. Now before looking at the output, first of all we need to write the values of x1, x2 and x3. So what is the value of x1? X1 means output of first XOR gate. So x1 is equal to what? Since 3 connections coming from D0, D1 and D2 to the first XOR gate, it means x1 is equal to D0 XOR with D1 XOR with D2. Now x2 is equal to, since only one connection, that is from D0 coming to the adder 2, so D0, that is the value of x2, and x3 will be D0 plus D1. So let us now try to understand the operation of this convolutional encoder with the help of one input, and that is m is equal to 1 0 1 1. So here I am going to prepare one table. The first column of this table is input, that is m, then content of shift register, so D0, D1 and D2, these are the content of shift register, and the next column is of output code word C. So we are getting x1, x2, x3, these are the 3 bits we are getting in the output code word C. So initially what we have considered, when no input is applied, initially the content of shift registers are 0, so obviously we are not getting anything in the output. Now when the first bit is applied to this design, the first bit 1 which will be coming into the D0. So this 1 will be coming in the D0 and still in D1 and D2 nothing is available. So accordingly we will get the output x1, x2 and x3. x1 is equal to D0 plus D1 plus D2. So D0 is 1, D1 is 0 and D2 is 0. So 1 plus 0 plus 0 is 1. x2 is D0, that is 1, and x3 is D0 plus D1. So 1 plus 0 is 1. Now the next input will be 0. So this 0 once again will be coming to, into the D0, and what happens, the content of D0 will be shifted into D1. So this 1 will be shifted into the D1 and content of D1 will be shifted into D2. So accordingly we will get the output x1, x2, x3 for these 3 bits. So x1 is the addition of all 3 bits D0, D1, D2, which is 1. x2 is D0 only, so 0, and x3 is D0, D1, which is 1. Now let us look at the third input, which is 1. So this 1 will be coming here. The content of D0 will be shifted here and the content of D1 will be shifted in the D2. So we are getting here the output 0, 1, D0 plus D1 is 1. Now let us look at the last input, that is 1. So obviously it will be coming in the D0. This 1 will be shifted here and this 0 will be shifted here. So we are getting the output 0, 1, 0. Now the operation is not yet over. For how longer this operation is supposed to be continue? So the statement is like until and unless the last input bit will not reach to the last shift register. So even though we are not applying any input, still not applying any input means 0 is there inside D0. The content of D0 1 is now shifting into D1 and this 1 will be shifted here. So we are getting the output here, that is 0, 0, 1. And one more time this operation will happen. So even though we are not applying any input, it means 0 here, this 0 will be shifted and this 1 will be shifted here. So we are getting the output here 1, 0, 0. And what happens now, since the last input bit this 1 is reached to the last shift register, that is D2. Now after applying the next clock cycle, what happens, we are not getting anything in the input, so it means the output is also 0. So basically this all things happen when we are applying the clock cycle. So this clock cycle is very important. So when we apply the next clock cycle, since nothing is there, so obviously this 0 will be here, this 0 will be here, so no input, it means we are not getting any output. So there is no meaning to look at this particular thing. So our operation is only valid up to the last input bit which will reach to the last shift register. So what will be the output here? So for input, that is m is equal to 1011, we are getting here the output code word C, which is, so for 1 we have got the output, that is 111. Then for 0 we got the output 101, 011, 010, 001, 100. So this is what our final convolutional coded output. This is all about the working of convolutional code.